Welcome to the ESI Africa live webinar, Africa's Nuclear Journey. First off, apologize for the late start. We had a tiny technical glitch which we have now been able to sort out. Today's webinar is hosted in collaboration with the African Utility Week conference, which is taking place next week on the 17th to the 19th of May in Cape Town. And our webinar today is endorsed by the Nuclear Industry Association of South Africa, NIASA. I am Nicolette Pomba-Fansale, editor of ESI Africa, Africa's Power Journal, and your moderator for today's live webinar, Exploring Africa's Nuclear Journey. Currently, there is only one nuclear power plant in Africa, and that is Koeberg Nuclear Power Station, which is situated in the Western Cape in South Africa, and not too far from where I live. Two nuclear reactors, which began operating in 1984, generate 5% of the country's electricity. And the South African government intends to increase the country's nuclear generation capacity by a further 9,600 megawatts by the year 2030. This plan has brought about considerable reporting in the media and discussion at dinner tables around the country. For this live webinar today, Africa's Nuclear Journey, we have invited experts to join us to provide insight into the nuclear energy sector and to answer your individual questions. I'd like to now introduce to you the expert panel, starting in no particular order. It's Tom Blees, who is based in Florida in the United States. He is the president of the Science Council for Global Initiatives and an international NGO, and is the author of Prescription for the Planet, the Painless Remedy for Our Energy and Environmental Crisis. I also welcome Anthony Cilliers, who is a nuclear engineering specialist and the program manager for nuclear engineering at the Northwest University in South Africa. Then we also have Knox Msebenzi, who is the Managing Director of the Nuclear Industry Association of South Africa. And lastly, we have GP Asantwere, who is a Senior Specialist at the South African Nuclear Energy Corporation and the Chairperson for the South African Young Nuclear Professional Society. I welcome all of our expert guest speakers. I also want to welcome everybody that is online today. I see we have quite an interesting audience from different sectors from across South Africa as well as other countries in Africa. And as a thank you gift for your time spent with us today, we are giving each attendee who remains to the end of the webinar a complimentary one-day pass to attend the Nuclear Power Africa Conference, which is taking place on Thursday next week. This conference is an authorized side event at the African Utility Week conference being held at the Cape Town International Convention Center. And registration information will be provided to you at the end of the webinar. The terms and conditions for this can be found on our website, which is www.esi-africa.com. So to start the discussion off, each of our guest speakers has prepared a short opening statement to set the scene. Thereafter, we will be examining questions on various issues. I'm requesting Knox Msebenzi to start with his opening statement. Knox, over to you.
Thank you. I just have a couple of slides that I would like to go through about basics of nuclear. I'm assuming that I'm not talking to experts in nuclear, but basically the arguments that are doing the rounds in the media these days are based on lack of knowledge about what nuclear is all about. So I think it's important that we get people to be informed about what nuclear is about. Basically, nuclear is just a source of the heat that is used to convert water into steam. Then the rest of the process becomes conventional, just like a coal power plant. So a lot of stories are said about nuclear and that sort of thing, but I think it's important to understand that. And then, secondly, just jump to my right, the issue about the cleanliness of the fuel compared to fossil fuels. In this environment where we're talking about carbon emissions, nuclear is by far the best option that is available for baseload supply. I'll also speak briefly about what is meant by baseload, because there's a lot of misunderstanding in the public eye about what baseload is all about. But before I get to that, I would just like to also deal with one of the biggest myths about nuclear. People associate nuclear power with nuclear bombs. The two are far from each other. Nuclear bomb material is never, ever used anywhere close to a nuclear power plant. So the nuclear fuel that is used in a nuclear power plant is not stuff that could be used to detonate a bomb. So the myth that people have that nuclear power amounts to nuclear bombs, unfortunately, it is not correct. We need to correct that. Going back to this about the cleanliness, it's one of the environmental friendly fuels that can supply base load. And it's good for the environment because there is no emissions whatsoever, except maybe in the construction phase where we are using conventional equipment. Nuclear energy, to emphasize the safeness of the nuclear energy, it is one of the highly regulated nuclear fuels of the world, and statistically, very few deaths are attributable to any nuclear power plants throughout the world. There's a big perception about nuclear being very expensive, but I think in many instances people are just looking at the installation cost of nuclear power plants, which are initially very high because of the span of the nuclear power plant. When you look at levelized cost of electricity, it works out that nuclear is it's not the cheapest, one of the cheapest source of energy. Now let me quickly address the issue about baseload. To run effective industry, smelters, refineries, factories, and hospitals for that matter, we need reliable energy that is available 24 hours, 7 days a week, 365 days a year. Unfortunately, some of these renewables are only available when the sun is shining or the wind is blowing, and therefore it's very important that we understand that the renewables can only be used complementary, but they have to be backed up by a reliable source of energy. So renewables are not yet able to supply base load because the storage costs are very prohibitive at this point in time. So a lot of propaganda or information about people can run a grid using solar or wind. That is just not true. When you look at the capacity factor, in other words, the amount of energy that any installation can give, nuclear is somewhere much higher than 90%, wind and solar around 20%, and therefore you find that 80% of the time that energy is not available. So in our situation where we're looking at industrializing, it is important that we have a reliable source of energy. Developed countries do have reliable sources of energy. Developing countries need also to have reliable sources of energy. Apart from fossil fuels, the other source of reliable energy is hydro, and we know that South Africa is not rich in water. And so nuclear offers a very good option. Thank you very much.
Thank you very much, Knox. Demystifying those myths are the very concerns that we will be addressing in this webinar today, specifically around the cost and whether nuclear is a clean energy. I want to now ask Tom to prepare to start with his opening statements. Over to you, Tom.
Okay. Okay. Hi, thanks for the invitation. Let's see, I clicked on my slides here. All right. I'm going to try to, let's see. Which one is showing Science Council for Global Initiatives now, right? There we go. Okay. I started this whole phase with writing this book, Prescription for the Planet, and on the slide there's a URL at the top that shows where you can download the book for free if you'd like to read it. So I'm going to just leave the slide on there for a little moment. And after I wrote the book, then a number of international scientists started a nonprofit organization with me called the Science Council for Global Initiatives. And what we do is we try to take the principles of Prescription for the Planet, that is a comprehensive plan to improve the standard of living of everybody on the planet using a high energy system that is environmentally benign. And we work not only with nuclear energy, but we work with transportation systems and waste recycling systems and all that sort of thing. So, but nuclear energy is a big part of it. So what I want to do is, in this introduction, is not talk so much about the specifics of nuclear energy, but explain why we absolutely need it. And the main reason why we absolutely need it is because the world population is growing so much that we're very likely going to have at least 10 billion people on the planet, probably by mid-century or shortly after that. And so we need to be able to provide not only the base amount of energy that people use today, but everybody wants a higher standard of living who live in developing countries. So, and we have to provide water and food for 3 billion more people than we currently have on the planet. So we are really seriously going to need a lot of energy. And this slide has a lot of text on it, but basically what this shows is that the world population is growing at a certain level there, that dashed line. But if people are going to want to be able to have a developed country lifestyle, the world energy demand is going to grow like the top line. And that would mean that everybody would have used the equivalent amount of energy as half as much as people in the United States use today. So we can see that even conservation and energy efficiency is good, but it's not even going to make a dent in the amount of energy that the world is going to demand. So we have to figure out where we're going to get it. And a lot of people think, millions of people around the world believe that we can get it from wind and solar, partly because that notion is fed by certain people. It's kind of a cottage industry. We saw this Scientific American in 2009 saying that we could do this by 2030 with wind and solar, and it's absolutely not feasible. But some people have tried to figure out how we can do that, and Google is one of the companies that really wanted to do this because they buy electricity from wind and solar farms. Whenever they go up, you'll see Google in there making power purchase agreements. And so they started a project called RE is less than C. They wanted to figure out how to make renewable energy, RE, cheaper than coal. And they hired a lot of PhDs, engineers and physicists to try and figure this out, and they spent tens of millions of dollars doing it, and after 4 years they came to the conclusion that not only could they not make it cheaper than coal, but that renewable energy alone just simply cannot power modern societies. There's just not going to be enough of it. Now other people have looked at this question too. 3 colleagues of mine from Australia did a study recently called The Burden of Proof, where they looked at all the different 100% renewable scenarios that a lot of various people and some universities have been putting out, and they came to the same conclusion that Google did, that there's simply no way to do it. Then just this week, I think, this paper came out that shows that for areas that have moderate insulation, in other words, where the temperate latitudes, where countries are like Germany, that actually you put more energy into making the solar panels, if you're going to use solar, than you'll ever get out of them in their lifetime. And so the idea of what they're saying in this paper is that Germany, which has invested just tens of billions of euros, actually I think well over 100 billion euros in solar, that they're actually that they could actually create their electricity more efficiently if they would simply burn coal. And this is a pretty radical assumption, but I'm putting this up there so you can go and read it. It's pretty solid. It's not saying that solar isn't going to work everywhere, but it's saying that for using it in countries where you're going to just essentially subsidize it, the reason that you can afford to subsidize it is just because we have lots of energy that's very high density that's allowing us to do that. So it's a pretty important thing that we get real about this. That a lot of people say that, well, we could continue to use coal and gas if we just figure out how to do carbon capture and storage, and we capture the carbon dioxide and we put it under the ground. And there's an awful lot of policymakers around the world that believe this is the case. But the problem is that in coal mines, like the one pictured there, strip mining, so much shale and mudstone is exposed to the air that a vast amount of greenhouse gases escape directly from the mining process itself. So that even if you took all the coal that you pulled out of the mine and burned it in coal-fired power plants and captured all that CO2 100%, a lot of times you're going to get more greenhouse gas emissions coming from the coal mine itself. So coal mining just simply is not going to work, even if carbon capture and storage is perfect. It's a similar situation if you look at gas. The gas lines that power much of Western Europe come from Siberian gas fields, and they travel thousands of kilometers, quite a few thousand kilometers actually, to their customers in Western Europe. And by the time the gas gets there, 40 to 45% of it is gone. Now, some of that is used in pumping stations, but a lot of it is leaking directly out. And methane, natural gas, has about 20 to 30 times the greenhouse gas effect of carbon dioxide. So again, even if you captured and sequestered all of the gas at the point of use, you're still going to end up with a huge problem. So how are we going to produce the electricity that we need to power the planet? And not just electricity, but things that we'll be converting to electricity. And we also have to consider the fact that we're going to have a lot of energy for desalinating water, because we're going to have to provide water for another 3 billion people. And the surface water supplies are already very stretched in a lot of places. So we got to figure out where we can get the energy. And so we look at fossil fuels and clean energy, and you can see that the so-called clean energy is a fairly small portion of what's providing energy in the world today. And of that slice, you can see that nuclear in the red is substantial, but still small compared to total energy, whereas wind and solar is tiny, tiny. So one question is, well, you know, nuclear is a lot more than wind and solar, but can you scale it up fast enough? And we saw in France that they could scale up to get to 80% nuclear in just 11 years using old-style reactors that required the building of high-pressure systems, pressure vessels, and that sort of thing. But in the United States and elsewhere around the world now, there are new designs that are developed and that are very close to being ready to build that are mass producible and smaller. Now this particular company called Thorcon in the United States has developed a molten salt reactor design that's modular, and that could be produced using the same techniques that are used in shipbuilding. As a matter of fact, they'd be built in shipyards, high-tech shipyards like South Korea has, where they built the largest ship in the world in 12 months for $89 million. And they started a company to build nuclear reactors, and they expect that in about 4 years they're going to have the first ones up online, and they would be able to build thousands of them per year. So at a very reasonable price, extremely cheap compared to what reactors cost today. The United States also had a development system for fast reactors, which I write about a lot in my book. And General Electric has this PRISM reactor, which is based on that technology, and that also is meant to be mass-produced and could be built by the hundreds or even thousands per year once you get the supply chain in place. And again, like the Thorcon reactor, this is a modular system, so you can build them in factories with really good quality control and move them onto the site. And with the last slide, one of the things that is a big concern of people is, what are we going to do with nuclear waste? But what we can do is we can use what's called pyroprocessing, and this is a system that uses a very simple and quite small facility that can recycle spent fuel from any of these types of reactors, including the type that we use today, and can make fuel out of it for PRISM reactors or for the Thorcon reactors or something similar. So we essentially have the technology so that the nuclear waste problem is solved right now, and I'm sure we'll talk more about that in the discussion. So I'll let it go at that. Over to you.
Yes, thank you so much, Tom. The democracy in Africa is definitely increasing and driving considerable technological developments, as we have seen in all the different technologies in the generation mix. Anthony, would you please present your opening statement?
Hi, everybody. I would like to present to you something that I'm very passionate about. First of all, with 9,600 megawatts of nuclear being planned for South Africa, I think it's extremely important for us to realize that it's not just about electricity, it's also about the human resources and the skills that we need to develop in South Africa. Hence the name of our webcast today is Are You On Board? So I would like to say, how can you get on board if you're not on board yet? And actually the plans that we've been making in trying to be proactive to get everybody in the country within a reach of nuclear energy, and that we can all make a contribution. So we developed something called the South African Network for Nuclear Education, Science and Technology, and the real idea there is to actually combine all the expertise in the country that's situated in industry, they're situated in universities, to get them together so that we can actually maximize the energy that we put into getting the right people skilled up for this big program that's coming. So what we're trying to achieve with this network is to say, the South African network, we try to get a suitably qualified and experienced nuclear personnel that will be employed by the Nuclear Science and Technology Program to be predominantly produced by the South African education system so that we can empower ourselves as a country. And I think that's something that we can really get excited about. A lot of things we hear in the news, we hear about cost and how much money is going to go out and how we're going to repay it. The real truth is that money can stay, a big portion of that can stay in the country, and it can develop our people, and it can change our whole economy into a knowledge-based economy. So we want to strengthen the nuclear science and technology education programs to better meet the future demands in terms of quality, capacity, and relevancy. Now, I always say quality, we've got great quality in terms of education in the country, but we need to build on our capacity so that we can get the number of people through and get them educated. And that's something I'm extremely passionate about, because that's really on the ground level where you see the difference in nuclear programs worldwide. We've also done education capability assessment to see what can we deliver as a country, and then we can determine where we need to send students maybe overseas to go and study there, and where we need some overseas help to teach our lecturers and so on. We've combined a number of universities. All of these names should look familiar to everyone. The members is Northwest University, which was basically the initiating university. And then we've got University of Wits, NMMU, University of Johannesburg, Cape Town, Pretoria, Stellenbosch, as well as even some of the smaller ones, University of Venda, KZN, Western Cape. We've got all of them in there as well. And then we've got a lot of experts sitting at Nexa that's willing to provide their expertise to develop the young people of South Africa into making a contribution in this nuclear program. So, like I said, this is something we can really look forward to. We've had great support from the Department of Energy and the Department of Science and Technology. They bought into this idea, and they're really supporting us very well in making sure that we develop the skills in time to be ready for the 9,600 megawatts of nuclear. Of course, we will need to get some people from outside, but as long as we can have a proactive plan to get as most people in here from South Africa in doing this, that'll go a long way in assisting us. What we're trying to do here is we're creating joint degrees between the universities, so that we can have students moving between universities, making use of facilities all over the country at the various facilities, research facilities, and that's something I'm very excited about. When you go to the US, you see at one university there's more facilities available than we have in our whole country, but in this way, the way we network it actually becomes available to all the students. We are planning to build a small research reactor so that students can train on that as well. And we also, once we taught these students, we will keep the saw sharp by offering them short courses on a continual basis and getting the people upskilled for this. And then we also develop some training programs for students specialized, like for the nuclear regulator or for people working at Nexa and so on. We also produce material that we offer, and we've created a little booklet together with Rosatom that we have students to better reach the young people out there and show them what nuclear power is really all about, because there's a lot of misinformation in the media about what nuclear is about. And then also we try to keep it relevant. We are in constant contact with the companies, the big companies working, the government institutions, and we try to keep in contact with them so that we train the people in the information they need to know. We don't want to teach something that they only can find a job overseas. We want to have people trained to make a difference in South Africa. So what we do there is we maintain a close link as well with these industries, and we identify certain projects that these people will be able to do at these different industries, and then we enroll the students in there so they can start working in the industry already while they're learning and while they're doing projects. That's something I'm really excited about, because that upskills you and it creates a specialist within the company that they work in. And we've seen a lot of successes coming from that initiative as well. For 2016, we are planning the Energy Management School, which I'll show you a pamphlet a little bit later. But we're planning the Energy Management School that we offer together with the IAEA, where we will find young professionals, about 45 of them all over Africa, to attend this and teach them about nuclear and the nuclear industry. It will be held close to Koeberg, so that we will also have a visit to the Koeberg nuclear power plant. We will be able to go in there and go and look at the inside of a nuclear plant. Probably won't be able to see inside the containment, but we'll be able to see a lot of things inside there. We're also doing some other projects determining the economic and social effects of nuclear programs, actually going way beyond just the electricity and the skills that we're developing. We also look at how does that impact the country, how does the country's GDP grow, and how can the economy grow by having this developed. We're working very closely with international industries as well as throughout Africa in the form of AfraNest, which is our mother network in Africa as well. And we also link with Europe in their network that they have. That's my opening statement. You can see a little pamphlet there. I'm hoping that I can get a list of all the attendees so we can send it out. But in October, the 17th to the 28th of October, the Nuclear Energy Management School will be held in Cape Town. Very excited about it. It's like a summer school for about 2 weeks. And students will have a chance to interact with each other, interact with specialists from throughout the world as well as Africa, and learn a lot about nuclear power so that we can be ready for this 9,600 megawatts that's coming. Thank you very much. Over to you, Nicolette.
Thank you, Anthony. That was a very passionate opening statement, and we can look forward to skills development and localization, which are key benefits that come along with the nuclear energy bill. I'm going to ask GP to now give his opening statement, which he will be doing with our PowerPoint presentation. Thank you, GP.
Oh, thanks very much. Good afternoon to everyone. My name is Kapal Sansore. As it has been said, I'm the chairperson of the Young Professional Society, which is also an affiliate to the International Nuclear Youth Congress. We are also part of the International Radiation Protection Agency through the involvement and affiliation under the South African Radiation Protection Association. So it is quite a big resume for the South African Young Nuclear Professionals. I think a couple of weeks ago, the State SA gave us a very worrying stats that 26.5% of unemployment rate that is currently in our country, which over 60% are our young professionals who are unemployed. So yesterday when I watched the news, when the President gave a very brief review of their meetings with labor and business, he said very two interesting things. One of it being that South Africa needs to accelerate inclusive growth, which will need to expand more investment opportunities. And he was also accompanied by the Finance Minister, who said a very positive note, which he said that we need to find new and innovative ways to search for new engines and growth, to find new ways of igniting growth and creating sustainable jobs so that our people that desperately need them can be employed and can change their lives. Now, one thing that I want to start with is that, you see, there is a level of lack of understanding in terms of what is the objective of integrated resource play. And a lot of people, I think, as has been said by Knox and other, we need to educate a lot of people to understand that what is an IRP and what does it stand for and what is its objective. So, just shortly, the main objective of the IRP is to provide a coordinated schedule for generation, expansion, and demand-side intervention programs, taking into consideration multiple criteria to meet electricity demand. We have heard from lots of professors and analysts that the growth is very low, and then therefore, if there is low growth, there is no opportunities for young people. Now, we believe strongly as the South African Young Nuclear Professional, based on the evidence that is being provided for by Quebec, and also NEXA and all other industries in terms of what they have contributed to changing the lives of ordinary South African youth, and also contributing significantly well into the economy. So we believe strongly that if we develop the youth expansion program, we can change our economic status, and then we can have a lot of positives which will be directed to over 60% of our unemployed youth, who most of them are our members. Now, we need to find ways of ensuring that this nuclear development or this nuclear expansion program fits very well into the scope of how the country can move forward, and also to ensure that the youth of this country benefits positively both from skills development, business opportunities, and career prospects. Now, just to make sure that this could be done, that there need to be a nuclear awareness that will be very, very taken at a high level to ensure that South Africans, who 50% of them can't have a constructive debate, do have a sort of a contributing factor by understanding what is nuclear, what is application, and what is benefit. So we need to ensure that the general perception, which is most often misinformed surrounding nuclear development, that it is changed, and then we needed to unpack it and clarify issues so that the citizens can make their informed decision around the subject matter without people feeding them with wrong information. So we would like to urge all the participants, including the industry, to go out there, have a drive to educate our people, especially the young people, so that they can contribute. I believe that if you can do that, the nuclear expansion program will be a success, not only to the country, but to the citizens themselves, which over 60% are our young people, our young professionals who are eager and desperate for this program.
All right, thank you very much, GP. I welcome listeners to send their questions in during the next half of the webinar. And I want to start off with a question that we have received from a listener who asks, I can't see any justification for the NNR to take until 2018 to approve the proposed nuclear build site. It could be done in a few weeks, could it not, is the question. I'd like to ask GP to respond to that.
No, because we've got regulations and there are requirements that need to be met before you can be granted a site license. These are some of the things that my colleague here, Israel Skoko, deals with it. They do a lot of site characterization. They do the safety, site safety report. So when NNR is submitted with those things, they have to review them. They have to ensure that what is being submitted meets the regulatory requirements. So that process takes a lot of time because it's resource intensive. NNR has to verify and also have to do their own independent analysis and assessment to ensure that the site where the nuclear power plant will be deployed, the potentially so, it is best suitable for that kind of technology, the community, the environment, and everything. So hence it takes a bit of time. It's not like me and you when you go for a driver's license, we get it in one day. This one is quite a different one. The nuclear installation site license takes time, and I'm fortunate enough to understand the licensing process. So those are some of the things that makes it a bit more, because NNR has to do an independent assessment and has to go through a public participation process also to ensure that our public understand what's coming to their shore, what's coming to the neighborhood. So it is important that this process is done honestly and is done in a manner that the public can have confidence in our national nuclear regulator, which myself, I'm very confident that they are doing an excellent job.
Thank you, GP. Tom, I'd like to ask you to also add to this question on a global perspective. How long does something like this normally take?
Oh, wow. Well, in the United States, it takes a ridiculously long time. It takes several years to do environmental impact statements and this sort of thing. One possible way around this that we can see in the future for countries all over the world is the advent of floating nuclear reactors. Russia's building one now, and the Thorcon system is also going to be a floating system where the entire power plant is on a ship. And you essentially, all you have to do is build a seawall and breakwaters as necessary, and the ship just moves in, and the only thing you have on the shore is you have the grid wires running down to the ship. Basically, it's like plugging in to a great big outlet. And in a case like that, it's going to be really easy to do and really fast. But if you're actually building things onshore, you know, generally, globally, you're going to have environmental impact statements or something similar to that, and it's going to take usually at least a year, but oftentimes more than a year, depending on where you're doing it.
This brings us to the question around, can my country afford nuclear energy? Seeing that the process is so long, I can understand why the cost would become quite expensive. Anthony, would you like to respond to that question?
Thank you, Nicolette. Yes, the question is always to say, can we afford it? And I think it's because we hear big numbers and we think that we're going to pay it out to some vendor country or company that's coming in and they're going to deliver it to us. And we need to look a little different at it. And that's the difference between something that you just buy and you use it up, and something that's an investment that's paying itself back over time. So the short answer is, can we afford it? It's really, can we afford not to do this? Like I said before, the change that a nuclear program brings to a country is not only limited to the electricity that's being sold, but it's actually the changes to the enabling of economic growth that it allows. And that's some analysis that we are doing, and we can actually see that the economic growth in a country from a nuclear program far outstrips the cost of a program like this. Now, of course, if you can't afford something, it's sometimes difficult to buy it. But I've always learned from my parents, if you want to buy something and you can't afford it, you have to work harder for it. Now, in this case, if South Africa wants to work harder, we need enabling facilities to enable us to work harder. GP mentioned the unemployment rate in South Africa. If we can find industries, build mining sectors, agricultural sectors, automotive sectors, if we can build all of that to actually supply jobs to people, South Africa can work harder, and then we can certainly afford or whatever we want. So doesn't matter what the cost is of a plant like this, it enables us to actually grow our economy and bring all the people in and start working. I think a little bit later, if there's more questions about the real cost of the nuclear plant, we can talk about that as well. But in terms of can we afford it, I think we should do it, and we should do it as quickly as possible.
Thank you very much, Anthony. We have another audience question, and I'd like to address this to Knox. The question is, when do we expect the formal request for proposal to be issued by the Department of Energy to the vendor countries?
We have been expecting it for a long time. Expecting it and actually getting it, those are two different things. I think the best people to answer that question will be the Department of Energy itself. We in the industry are not in the know in terms of when that would happen. There is a process that government must take, and I think the best that we can do as industry is to assist government in terms of it reaching its decisions early enough. One of the things that we need to do as industry is to equip the government with sufficient facts and information to be able to convince the public and the political stakeholders that this is the right thing to do.
Thank you very much, Knox. We have another question from the audience, and that is addressed to Tom. If the UK and France, together with China, can't make it happen, why should South Africa be able to?
The situation with the UK and France, the Hinkley reactor is a European, what they call an EPR, which is an AREVA design that is being built. The first one's being built in Finland, and it's notorious for its high price, its slow build, and it never should have been built, actually. And there were many nuclear engineers in France who, when AREVA decided to build it, told them, look, this is obsolete already. The design's been on the drawing board too long, and yet they went ahead and built it because it's very difficult to turn around a big company like AREVA. And so what happened was AREVA is very politically powerful in Europe, and the people that wanted to build nuclear in the UK had been frustrated for years that they just couldn't get a project going, and AREVA came over and goes, oh, well, we'll build EPRs for you here. And so they thought, well, this is finally a way that we can get restarted with nuclear. And so there was this air of resignation when France told the UK how much money they were going to demand for the electricity from this thing. And at the time I was over in England talking to people in their Department of Energy and others, and they were going, oh, heck, we know it's a lousy deal, but, we have to do it because we got to get nuclear restarted. And so it is a lousy deal. The UK is committed to paying way too much for the electricity from the Hinkley plant, and if they're lucky, they're going to be able to get out of it and not build the thing. Because now there are other nuclear projects going on in the UK that are in the early stages, and the reactors will be more inexpensive and actually safer. So, it's the EPR is kind of a worst-case scenario, and people who are against nuclear power love to bring it up and say, well, you can see nuclear power will never work because it's uneconomical, but that's not the case. The EPR is uneconomical, and it's a situation where I think when you see the AP1000 that's coming on for the first time in China later this year, and they're being built also in the United States, I doubt you'll see anybody ordering AP1000s anymore, because the technology is obsolete compared to the passive safety type reactors like the AP1000 and others that are coming online.
Technology is...
Nicholas, maybe the question we should ask that person is, if China, South Korea, and Arab Emirates can do it, why can't we do it? So let's change the question around. Instead of just emulating some of the perceived failures of Europe, China and South Korea are very successful at it. Why can't we do it?
Thank you, Nux. We have another question from the audience, and this is again around the cost and what is it that we can put in place, governance procedures and processes to prevent a repeat of possible corruption and personal or political party enrichment. Anthony, would you care to answer that first, and then I'll ask Nux to add to that response?
Thanks, Nicolette. Yes, that's actually a very difficult question, and I think it's on the lips of everyone in South Africa in terms of corruption and things like that. I think our constitutional system is designed in such a way, first of all, to allow a transparent process in government to do these things. Now, of course, the trust has been broken in some instances in the past. But I think it's very important to note that with our system, there's this responsibility, this public responsibility, and the responsibility of Parliament with all its opposition parties and so on, to actually take up that responsibility and actually be the watchdogs for possible corruption in any industry, not only in nuclear. I mean, I think the mention here, just because it's such a big deal, not necessarily that it's nuclear. But that's the case. What I've seen in South Africa is actually the opposite happening. People are afraid of corruption, and they say we should simply not do something because of this risk that we're facing. And I think that's the wrong way to go about it. We should rather say this is a risk, and how do we manage that risk? So we should put procedures in place. We've also seen, and I'm welcoming it absolutely, that they're thinking of incorporating the new renewable plan into the IPP office, the the Independent Power Producers Office, which has got a number of these transparency issues, and it becomes a partnership between private industry and government, and it becomes a much more transparent process being followed. I'm quite surprised always when I hear that people say that the nuclear deal has been veiled in secrecy for so many years, because I'm following it quite closely in the media, and it's probably the worst kept secret in the country. There's nothing been signed, but there's a lot of information that's already been available in the media to everyone. Every sentence obviously starting with it's veiled in secrecy, but I don't know what is really so secret about this deal. So having things out in the open, having people being involved, the media being involved, the public being involved, and the private sector being involved, I think those are the procedures that we should take up our responsibility to be the watchdogs in such a case. This risk is there all over the world. It's not just limited to South Africa. It's there for all industries. It's not just limited to nuclear. It's always a risk. It's something that we should be managing. Thanks, Nicolette.
Yeah, I agree entirely with Anthony's assertion. This year we are facing a drought situation in this country, and we may need to import enough of maize. Are we going to say, because we are afraid somebody might be corrupt, let's not import the maize, let us starve to death? What kind of a nation would we be that is scared of doing projects because we are afraid that somebody will be corrupt? We need to manage the corruption and make sure that it does not happen. We cannot let people die of HIV because we cannot buy antiretrovirals because we are afraid somebody is going to be corrupt. This notion that we don't do something because we are afraid somebody is going to steal the money, that's just unfounded.
Thank you very much, Knox. I just want to say that all the questions that we are receiving that we don't get to today, we will be sending this on to each of the speakers to answer so that you will get a response. I'm going to have to wrap. We just got cut off there briefly, but continuing with the webinar, we have an interesting question from a listener around the given plan to build an additional 9,600 megawatts. Is there any renewal of the pebble bed modular reactor project? Anthony, could you please answer on that?
This is actually quite an interesting question. If you look at the IRP 2010, it talks about 9,600 megawatts of nuclear, and doesn't specifically state the technology. But if you also look internationally to what the targets are for Generation 3 plants and Generation 4 plants, it looks like we'll be looking at the last group of plants being built from now until 2030 of Generation 3 plants, whereafter we will be starting to build Generation 4 plants, which the PBMR falls nicely into that category. So the time really is ripe to start opening up this plans again. Of course, the IRP 2010 only looks until 2030. But beyond that, if our economy is growing and everything is going well, and I foresee that is going to happen, then we should look beyond 2030 and see what the next plants will be. So the time is certainly right for looking back into the PBMR project for the next generation of plants. I think it has been a bit before its time, the original one, but it's definitely time that we start looking at it beyond 2030 for the Generation 4 plants, certainly. Thank you.
Thank you, Anthony. We have another question from the audience, and then we will be wrapping up. And this is around the Renewable Energy Independent Power Producers Program, and looking at the recent success of this program that now has the cheapest new build energy supply technology in South Africa, and the combination of renewables with a flexible complementary generation fleet would likely be the best way to meet any new demand as we grow into the future. Tom, if you would answer on that question, please.
Yeah, I'd be happy to. I think the critical part of that question is when they talk about the flexible complementary generation fleet, whatever resource technology that may be. The problem with renewables, with wind and solar, is that you have to have sufficient generation capacity to meet peak demand of your system, even if wind and solar is providing nothing, which it sometimes does provide nothing. And sometimes for weeks at a time it provides nothing. So essentially, if you're talking about building a system of increasing capacity, you're talking about building a conventional system using either gas, coal, or nuclear, or hydro if you have it, but I think that's kind of not really in the mix right now. And then you're building wind and solar on top of it. So even if wind and solar is very cheap, you're still building an entire system and then building wind and solar on top. And if you can afford to do that, and you'll get some saving of fuel from the gas plants, for instance. But you're also building, say, a natural gas plant, which is generally the way it's done, that is only going to be running some of the time. So it's difficult to find a utility or to find the rationale for building a state-of-the-art gas plant that's only going to be running half of the time, or maybe 60% or 70% of the time. And so generally what happens is people build cheap gas plants that aren't state-of-the-art, that actually aren't as efficient. And ultimately, when you get down to it from a greenhouse gas point of view, you're not saving anything, especially in countries that don't have really, really a lot of sun, as I pointed out in that recent study. So I think South Africa can spend its money a lot better building nuclear power plants that are going to be able to provide power whenever it's needed, no matter what the weather.
Thank you very much, Tom. We've come to the end of our webinar, and I'm going to ask each of our guest speakers to give a short closing remark to round off the discussion and leave you with a thought-provoking statement. If you would please give your closing remark.
I think the only thing that I would like to say to the audience is that when we look around the world, there are in excess of 70 nuclear power plants being built currently. And unfortunately, here in South Africa, we are still debating and arguing instead of doing stuff. If we'd done this a long time ago, 2007 or even earlier, perhaps some of the issues that we've seen with load shedding would not have happened. But unfortunately, we keep on debating. I think we are behaving like high school students who belong to a debating society. We want to debate things until the cows come home. Let's just get on with it and supply power to the nation.
Thank you so much, Mark. Anthony, and what is your closing remark for the audience?
Well, I want to close with a little bit of a imagination play that I like to play, and that's thinking ahead until up to the point of 2030, maybe 2040. In the 1960s, South Korea was the second poorest country in the world. They embarked on a nuclear program where they uplifted their people. I actually saw a picture of what Seoul looked like. It looked like a shanty town before the program. People were living in small houses, wooden houses, and they were stricken with poverty. They embarked on a nuclear program. Who would have thought something like that? And they've changed their country around to be an economic powerhouse. And my imagination and my view for the future is 30 years from now, what would South Africa look like if we have industries that can grow, if we have a vibrant economy where we don't need to worry to talk about poverty anymore or the gap between income. These things are a thing of the past, where our people can be empowered and we can work together, and we can create a country that's playing in the world as a real powerhouse and producing materials where that is the issues of the day and not the problems that we're talking about today. And if you can imagine that, I think we can achieve it. Thank you.
Thank you, Anthony. And lastly, GP, thoughts from a young scientist.
Well, I believe that for us to develop any kind of technology, we need to strongly build technical competency, knowledge base, and that can be done through government and business, as the President said yesterday. So we strongly believe that the nuclear bill can provide this kind of opportunity where a lot of young people who are distressed, unemployed, and misdirected can participate and can be part of this, and then we will not have issues of fees must fall like we're currently having. People cannot afford to universities. I mean, if we've got a nuclear program, people can be taken overseas, they can be developed, they can come back and plow back to the community, and we build a better South Africa. Thank you.
Thank you so much, GP. And then from our guest speaker based in Florida in the USA, Tom, what are your closing remarks?
I'd just like to tell the audience about a friend of mine who was chief science advisor for the UK's Department of Energy for many years. He was a physics professor at Cambridge before that, David Mackay, who died just very recently, last month. He wrote a book called Sustainable Energy Without the Hot Air, and he looked at just at the numbers, like how can we get our energy, what makes the most sense. And he was very data-driven. His book was always free online and still is. If you go to withouthotair.com, you can download it. And what David did was he looked at all different sorts of energy sources, wind and solar, waves, tides, everything. And over and over again, he came back to nuclear. And some people would ask him, well, you know, why are you pro-nuclear? And he said, no, I'm pro-arithmetic. And I think that when you look at the cost of nuclear, and by the way, I think the $1 trillion idea is way too much, and that South Africa can do it a lot cheaper than that. You just, you know, ultimately take a tip from David, download his book, take a look at it, and add up the numbers. And I think if you do, you'll see that nuclear power is going to definitely be the way to go.
Thank you very much, Tom. I just want to remind everybody that the webinar will be available online on demand on www.esi-africa.com, and that your questions will be sent through to the guest speakers to respond to in greater detail. I want to say thank you to our guest speakers for giving of their time and knowledge, and to all the participants for joining us this afternoon. I hope to see you next week at the Cape Town International Convention Center at the African Utility Week Conference and Exhibition. Thank you for listening.
Thank you.